Bismillahirrahmanirrahim. It is our lecture number 12, and today we are doing the graphs of different function from chapter 1 and the exercise which is related to our today's topic 1.5 graphs. In today's lecture, we will discuss the graph of explicit function, graph of implicit function, graph of parametric equations, and graph of discontinuous function. And you have very well idea about the explicit function and implicit functions. We have done these two topics in our previous exercises, as well as we have done the parametric equation, and we know the condition on which our function becomes discontinuous. These are the different graphs of explicit function. I just want to show you which functions are explicit functions and how their graphs are look like. Now the first one is a constant function. You can see any number f of x is equals to 2, 3, 4, 5, 6, any number. Whenever we have any numeric number in our function or graph look like this. Now the second one is the graph of f of x is equals to x, and here we have this type of a graph. And now this one is absolute function. For absolute function, we know that whenever we define the absolute function, we have two types of values of our function. The first one is positive and the second one is negative. That's why we have this type of graph. This is the quadratic function, cubic, square root, cubic root. This one is reciprocal function, f of x is equals to 1 by x. When f of x is equals to 1 by x, then we have f of x is equals to 1 by x square. These are some more examples of different graphs. Now graph of exponential function. The graph of exponential function when f of x is equals to exponential power x. This is an exponent function, and we know that the value of e is 2 point something, and that's why we in such type of function we give different values to its power x, this power x, because this e is a constant number. We have a constant value for this e. So whenever we have some variable number, variable is in the power of some constant number, we called such type of function an exponential functions. I will discuss it further. These are the graphs for the common logarithmic function. Now the second topic is graph of an implicit function, and in your book there are two examples for the implicit function. The first one is the circle and the second one is the ellipse. Okay. Now here we start our exercise. Sorry, before exercise, I would like to give you some explanation that how to draw graph. You must keep one thing in your mind whenever you are going to draw graph. Graphs are very important, and whenever we have explicit functions, explicit function, graphs of explicit function, and we know that which functions are known as explicit function. All those functions are explicit function in which we have all if we have two variables in our equation, like I will give you an example for this. Let's say we have x square plus y plus 2 is equals to 0. And if I can write this, y is equals to minus x square minus 2, means I am able to separate these two variables, one variable to left hand side and the other variable with the constant or any extra term to the right hand side. If whenever I am become able to do such type of separation, I call this equation an explicit equation. And whenever we talk about the functions, so such type of function is known as an explicit function. Right? Now, today's topic is how to draw the graph of explicit function. In your book at page number 32, the first example of the explicit function is the f of x is equals to a power x. Now, if we want to draw the graph of such type of a function, we know that in this function f of x is equals to a power x. This a is a constant number. This a is a constant number and it must be greater than 0, right? Now, how we make the graph for this function? We know that x is equals to, first we make a table. Here I have x and here y is equals to f of x, and in our example we have a power x, right? Now you can give different values to this x. Suppose the first value is start from the negative, then 0 and positive. First value is minus 4. So what we do, and one more thing, that here we take a is equals to 2, means we fix this constant number a is equals to 2. So what happened when I give x to the value minus 4, this function becomes 2 power minus 4. 2 power minus 4 gives you 0.0625. You can calculate it. For minus 3, 2 power minus 3 is equals to 0.125. Similarly, minus 1, 2 power minus 1 is equals to 0.5, means 1 by 2, that is 0.5. Then 0. For 0, what we have? 2 power 0 is equals to 1. Okay. Now the other value come to the positive side. For 1, 2 power 1 means 2. For 2, 2 power 2, that is 4. Then 3 means 2 power 3 is 2 2s are 4, 4 2s are 8. For 4, 2 power 4 is equals to 16. Now by doing this simple calculation, your table you have make this table, you can make this table, and the concept is very simple. You are going to give some values to this x, and with giving different value to x, you can calculate the corresponding value for y. When minus 4, you have this, minus 3, minus 1. You are giving different value to this x, and with the and finally you get the corresponding values for a of x. Now the question is still here. Now how we make the graph? Okay, now you just this is your x-axis, this is your y-axis, okay. Now we know that this is the positive side of x, and this is the center point 0, then 1, 2, 3, 4, 5, 6, 7, 8. Again -1, -2, -3, -4, -5, -6, -7. Similarly, -1, -2, -3, -4, -5, -6, -7, and so on. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Now, what we are going to do? We just join these points at x. When at x we have -4. Where is the -4? This one is the -4. The value of y. This is the x-axis, this one is the y-axis. So when you have -4 at x-axis, what is the corresponding value? This one is the corresponding value, and that is 0.0625. 0.0625 is the value. 0.0625 means less than 1. So here you have some value here, this below to this 1. Okay, the next value is -3. This is the -3 at x-axis, and y-axis is 0.125. Very small change between these 2 points. Then 0.5, half of 1. I'm going little above to 1 because the values are very small. Let me settle down this. Okay, now the first value is over here, the second value is here, then the third one from 1 -1. When we have -1, we have 0.5, this one, and then at 0 we have 1 value. When x-axis 0, y-axis is 1, and then when we have 1 at x-axis, positives come to the positive side, 1, the y-axis is 2, then 2 and 4, 2 and 4. When x-axis is 2, y-axis is 4, and when x-axis is 3, y-axis is 8. This here. Yes. Now if you join all these points, we have this type of a graph. Yes, we have such type of a graph, and I can show you this graph over here. Yes, this one. This exponential power x like this type of graph we get. So when you join the points, you can get such type of a graph. And for making graph, it's very easy. You have just whenever you are going to draw any graph, first you decide the values for x, and and when you put these values of x in your function, you are able to get the corresponding values of y. And by x-axis you can draw the x-axis and y-axis, take all the values of x at x-axis and the corresponding values of y at y-axis, and whenever you join these points, these corresponding points, means when you have -4 at x-axis, you have 0.0625 at y-axis. When you have -3 at x-axis, at y-axis you have the point 0.215. Similarly, you can obtain these different values, and when you join these dots with each other, you can get you can get a shape, and this shape is your graph. Now, the second example is exponential function. By doing the same thing, you can find the graph for the exponential function. Then the log function. At your book, you can see the graph function, and the graph function, natural log, common log, exponential function. These are the examples for the explicit function. Uh, mm, there are uh, there are different. There are so many other explicit function or linear function. Linear functions are explicit function, and the other function. All those equation in which we can separate x and y easily, we call them an explicit functions. So there are so many examples of explicit functions. You can we will whenever we will solve the paper, I will show you the different type of explicit functions also. Now these in your book, as far as your book is concerned, you have two type of explicit functions given in your example. The first one is exponential function, and the common logarithmic function, and the natural logarithmic function. Now the next topic is implicit function. Implicit function, which the explicit functions are those functions in which we cannot separate the variable easily. Now implicit functions. Implicit functions. Now in implicit functions, the one very important example, that is the example of a graph of a circle, graph of a graph of the circle. So the equation of the circle is of the form x square plus y square is equals to a. And if we have a is a constant, and if we take a is equals to 2, so what happened, we have this equation become x square plus y square is equals to 4. Now we have to find the graph of this function. So what we do, we are going to try to separate these variables. So 4 minus x square, and when we take the square root, we have y is equals to plus minus under root 4 minus x square. Means at the same time we have two values for this y. One value is positive and the second value is negative. And all those functions are the implicit functions, in which I have told you in my first lecture before 1.1, we have done the vertical test, vertical line test, vertical line test. The vertical line test is used for the confirmation of the graph, means the graph, this vertical line test is used used when we are whenever we are trying to find the given graph is function or not without doing any calculation. Okay, means I mean to say that whenever we draw a graph and we are not doing any calculation, just in one look we can say whether the graph is a function or not, and this can be happened by doing this vertical line test. Means if I the previous look at the previous graph which I have made here, this one. If I draw different lines on this graph, these are the different lines. You can see that my all lines are bisecting the graph at a single point. This is the single point. This line bisect this graph at this point. This intersect at this point, and so on. You can draw different lines, different number of lines, but you can see that these all lines intersect this type of graph, this type of an explicit graph at a single point. Means this graph is a function. But whenever we have this type of a graph which I'm going to draw here, this type of a graph is not a function. Why? Because whenever we apply a vertical line test on such type of a graph, bisects the graph bisects the line bisects the graph at more than one point. That's why we say that the given graph is not a function. Now here we have two functions. Y is equals to plus under root 4 minus x square, and y is equals to minus under root 4 minus x square. So we say that if we made a table x now we are going to take different values for x 0 1 under root 3 2 minus 1 minus under root 3 minus 2 and so on. And whenever we are going to calculate the corresponding value of y for these values of x, what happened when x is equals to 0, y is equals to plus minus 2. You can calculate this over here. X is equals to 0, y is equals to plus minus under root 4 minus 0 square, means plus minus under root 4 means plus minus 2. So when x is equals to 0, x and y, the points are 0 and plus minus 2. So and we can write these this ordered pair over here at x, y is equals to plus minus 2. Now when x is equals to, when x is the next value is 1, when x is equals to 1, y is equals to plus minus 4 minus 1 square, plus minus 4 minus 1 means plus minus under root 3. So the ordered pair become equals to 1 and plus minus under root 3, means when x is equals to 1, y is equals to plus minus under root 3. When x is equals to 1, y is equals to plus minus under root 3. For under root 2, we have plus minus 1. For 2, 0. For minus 1, under root plus minus under root 3, 1 and 0. Now we are going to draw the graph for these values. What we have For positive value, this graph is for positive values. Now for this is 0, 1, 2, 3, 4 and 5. 1, -1, -2, -3, -4 and -5. 1, 2, 3, 4 and 5. -1, -2, -3, -4 and -5. Now at 0, here we have 0 at x-axis. The value of y is +2. This is +2. So first value is here. You, at this moment you just ignore these negative values. Just talk about I'm here talking about this. These are all positive values. Okay, you just at the moment you just ignore these all negative values. For 0 we have +2, this one. For 1 we have under root 3. Under root 3 means we have the value of less than 2. 1.73, I think, the value of under root 3. So here we have for 1 we have this value between this 2 and 1. Now for under root 2, whenever we have under root 2, we have this value +-1. At y-axis we have +1, this value. One second. I draw this graph. To explain you easily what I am going to do. What 0, 1, 2, 3, 4 and 5. 1, 2, 3, -1, -2, -3, -1, -2 and -3. So for the first value is 0, and for 0 we have y is +2. This one. Then when x is 1, we have under root plus minus under root means here we are taking just positive value. So the second value. Now for third value, when we have under root 2, the value of y is 1. Value of y is 1 here. So when we draw the graph, we join these values. We at 2 we have 0. This you can see we have such type of graph, and for other value when are going to this we have this -2. From -2 we are passing through. Actually on this board it's very difficult to draw these graphs, but I try my level best. Okay, now this is the upper part. This is the positive part of your circle from -2 and 2. Okay, now this is the this one is the upper part of, or we can say the positive part of your graph. Now this graph, I have made this graph for all the positive value of our circle. Now here I'm going to draw the graph for the negative value. You can see you can obtain the graph like this for the all negative value, for -2, minus under root 3, -1, minus under root 3, for all these values. And when you combine these two graph, this one is the for the positive graph, this one is the for the negative values graph, and when you join these two graphs, you are able to draw a complete circle. This one. When you when you unite these two graphs, you are able to draw a circle. Now, the point is whether this graph is a function or not without doing any calculation. So for here we are going to apply the vertical line test. Now you drop different vertical lines on this graph, and you can see the all single line intersect the graph at two different points. The first point for first line number 1, the line intersect the graph at this point and this point, and line 2 also intersects the graph at this point and this point, and this thing happened at so many times as much as you have dropped the lines. Means the vertical lines intersect the graph more than one time, which indicates that the given graph is not a function. Circle is not a function because all vertical line intersect the graph more than one point. Here you have another example, the graph of the ellipse, and you can also draw the graph by doing the same calculation. And the parametric equation, graph of the parametric equation. Graphs of parametric equation. Metric equations. Simple, we know that the example is x is equals to t square and y is equals to t, and the range for t is from -2 to this +2. Now when you make the graph, first you have to make the table for this graph. T, then x, then y. Let's say we have different values of t, -1, -2, 0 and 1, 2. For these values you can calculate x. When t is -2, x is -2 square, means we have 4. When when t is -1, x is -1 square, means 1. When t is 0, x is equals to 0 square, means 0. 1 square, 1, then 2 square, 2. So we can say for the different value of t, -2, -1, 0, 1, 2, x is first value of 4, then 1, 0, 1 and 2. Similarly, the same calculation happened for the y. When t is -2, y is also -2, -1, 0, 1, 2. So y is -2, -1, 0, 1, 2. Now you just make the graph. First you make the graph for t and x, then for t and y, and finally you join the graph. And this type of a graph is look like this when you draw the lines. Right? Now, when the function is continuous or discontinuous, this is the very simple concept. Whenever you have no breaks in your graph, no continuation, like if your graph is look like this, there is a continuation, there is no gap between any 2 points of your graph. It's a continuous graph. This is the continuous graph. All these are the continuous graph. But when we have such type of a graph, look at the difference between two. There is this discontinuation between the two lines. This is the graph of a discontinuous function. Now come to the exercise. Exercise 1.7. Sorry, 1.5. 1 point exercise. Exercise 1.5, the last exercise of your first chapter. Okay, the first question is, draw the graph of the following equation. Draw the graph of the following equation, and the first part of your first question is x square plus y square is equals to 9. And this is the same equation as we have done in our example. And what happened? Y is equals to plus minus under root 9 minus x square. And when first you have to find the domain and range of your function. You can write here as we have done this topic also, how to find the domain, how to find the range for this function, which is the domain and which is the range. Here we have x belongs to -3 to 3. So the values of x is, or domain is, from -3 to +3. -2, -1, 0, 1 and 2. For these values you can find the range of your function. The corresponding values for y, you can put -3 over here and get the answer. The first one is 0, then plus minus 2.24 plus minus 2.83. For 0 you have plus minus 3, for 1 you have plus minus 2.83, and for 2 you have plus minus 2.27 and 0. These are the corresponding values, right? And similarly, as we have done in our example, first you make the graph for the all the positive value. You take the x-axis, and then for y, you just take the positive value of y. The first graph is for all the positive value of y. Then again for second graph, again you take the x values, but at y-axis you just take the negative values, and then make the another graph. And when you join these two graphs, you can able to get the complete graph of your circle. Similarly, the second part, I'm going to solve the third part, that is y is equals to exponential power 2x. The third part. Okay, now the third part. The third part is y is equals to exponential 2x. First you can give two different values of your x. X is equals to -2, not equal, you just make the graph, the table, -2, -1, 0 and 1, 2. And for these values of x, you can find the values for y. And when y is equals to, when x is equals to -2, x is equals to -2, what happened? Y is equals to exponential 2 into -2 exponential -4. and you know that the value of this exponent is 2.7 something. You can give the value 2.7 power minus 4. You can able to calculate this value, and this value is will be equals to 0.02, then 0.14, 1, 7.39, and 5, 4.6. And when you join the graph of this function, take some values at x-axis and y-axis, and you can see you are going to get this type of a graph for y is equals to exponential 2x. Now the second question of your exercise, graph the curves that has the parametric equation. Okay, now for parametric equation, question number 2, and that is x is equals to the first part, x is equals to t, y is equals to t square, and the range of t is less than or equals to minus 3, greater than or equals to minus 3, and less than or equals to 3. This is the same a question as we have done in exercise. So I'm going to solve the third part of your question, that is x is equals to secant theta and y is equals to tan theta. Okay, x is equals to secant theta and y is equals to tan theta. Now x square minus y square is equals to secant square theta minus tan square theta, and x square minus y square is equals to 1. Why? Because we know the this formula, that when 1 plus tan square theta is equals to secant square theta. So secant square theta minus tan square theta is equals to this 1. That's why I have written here x square minus y square is equals to 1. And when we obtain the value of this y is equals to 1, x square minus 1, y square is equals to x square minus 1, and y is equals to under root x square minus 1 with plus and minus sign. And you know that how to draw the graph of this function. Okay, now the graph of this function, here we have the x value and here we have the y, which is equals to plus minus under root x square minus 1. X is minus 3. You can calculate it. This become is equals to 2.83. When x is minus 2, plus minus 1.73. When this is equals to minus 1, y is equals to 0. For 1, 0, 2. For plus minus 1.73, and for 3 this is plus minus 2.83. You just put the value of x in your function and get the values of y. Okay, now for scale, whenever you decide the scale along x-axis 1 square. 1 square means in your graph paper you have this type of a graph paper, right? Now 1 square is equals to 1 unit. When this is your x-axis, if you draw the graph for this x-axis, I change the color of my pen. Okay, if you have this graph, leave it. This is for your x-axis and this is your y-axis. This is your y-axis. This one unit, this one along x-axis, this one box, this one square is your 1 unit. 1 unit. And along y-axis, y-axis, 1 square is also equals to 1 unit. Sometimes you change the graph, means you can say 2 square is equals to 1 unit, and you are taking 2 squares from here to at this point to this point. You are taking 2 squares is equals to 1 unit, but it is very easy when you take 1 square is equals to 1 unit at x-axis, and similarly at y-axis you also take 1 square is equals to 1 unit. Now first we have made the table, then we have decided the scale, and now we are going to draw the graph of our function. This is the x-y axis, x-axis, and when you can see, you can draw the graph for you obtain this type of a graph of this function. Just draw the graph, just draw the lines, and you can see the graph is very easy, and you can easily draw all the points and join them and obtain this type of a graph. Now the third question is of a draw the graph of the function defined below and find whether they are continuous. And sometimes the piecewise function is sometimes not a continuous function because of their different boundaries. So here we have the third question, question number 3. Question number 3, the first question is y is equals to x minus 1 if x is less than 3, and this is equals to 2x plus 1 if x is greater than or equals to 3. Okay, now when we draw the table of this function, what we have, x, for x we are giving different values to x, minus 1, minus 1, 0, 1, 2, 3, 4, 5 and 6. Now for first value, when y is equals to x minus 1, for minus 1 and minus 1, minus 2, 0 minus 1, minus 1, 1 minus 1, 0, then 2 minus 1, 2 minus 1, 1. Now for this function, we have the value x. We have all values of x which are less than 3. So less than 3, we just stopped here. Why? Because our x has the limit less than 3 for this function. Now the another function is 2x plus 1. 2x plus 1, 2x plus 1. This is the first function. This is the second function. And this for this function, our values are started from x is greater than or equals to 3. X is greater than or equals to 3 means in this case x has the first value is 3 itself. So for 3, when x is equals to 3, this y is equals to, this is also the value of y. So y is equals to x is equals to 3. So y is equals to 2x plus 1 means 2 into 3 plus 1, 6 plus 1, 7. So the value of y is equals to 7. Similarly, when we put 4 in x, we get y 9, then 11, and then 13. So these are the different values for first function and your second function. Now when we make the graph of these function, 0, 1, 1, sorry, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, -1, -2, -3, -4, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5. Okay. Now, when x is, see the table also, when x is equals to -1, x of -1 is equals to -2. So this is the first point. When x is 0, y is -1. X is 0, y is -1. When x is +1, y is 0. When x is 2, y is 1. And then when x is 3, y is 7. So first I will join the first graph. Sorry, here we have the point. You take just a straight line over here. And the second graph is 3, 3 at 7. Then at 4 we have 9 here. And we have this type of a graph. Sorry. Our graph is going upward. There is no such type of a point which join these 2 points. So that's why there is a gap between our graph. So such type of a graph is a discontinuous graph. Discontinuous graph. Discontinuous graph. So the rest of questions are also the same one. Inside the second part is a continuous graph. The third part is also a continuous graph. I have done for you the first part because this graph is not a continuous graph. At question number 4, find the graphical solution of the following equation. The last question of exercise. Question number 4. X is equals to sine 2x. Let's say, which implies that x is y is equals to x. And what is y? Y is sine of 2x. X must lie between minus pi to pi. This is the domain of this function. So for table, when we draw the table, what we have? X 90 degree, then minus 60 degree, from minus 90, minus 60, minus 30 degree, 0, then positive 30 degree, plus positive 60 degree, and then we have 90 degree. This graph is for first function. When we have y is equals to x, we are going to make the table for this function. When x is equals to this, y which is equals to this x, what has happened? Minus pi by 2 means minus 1.6. Again, minus pi by 2 is equals to minus 1.6. Then minus pi by 3, this is in degree, you are converted into radian. That is minus 1.05. Then minus 0.52, 0, 0.52, 1.05, then 1.6. Similarly, now you are going to make a table for y is equals to sine 2x. Again, we have x minus 90 degree, then minus 60 degree, 30 degree, 0, 30, 60 and 90 degrees. The same values for x, but here we have a different function. Y is equals to sine 2x. This table is for y is equals to sine 2x. When you calculate it, you get 0.87 minus 0.87, 0, 87, 0.87 and 0. And when you make the graph for first values, you have the graph for first function, you have such type of a graph. But for the second function, as you have a sine function means you have this type of a graph, this one. And this is from minus 90 to positive 90. Now you can see the graphical solution is point of intersection of two graphs. Where the graph are intersect with each other, the first point is this, and this is the first point, and this one is the second point. These are the 2 points where our graph or both graphs intersects each other. And if when you find the value for these graphs, you are going to get your answer. And this is minus 54 degree, and this is positive 54 degree. And the third solution is over here at center point. They're also intersecting each other, and this is the solution of your this part. Now this is the end of today's lecture, and if you have any problem, you can contact me on my my number, and please give me any kindly give me some feedback of my lectures so I can able to solve your problem. Thank you very much.